G'day everyone, Percy here from TopTechSkills.com. If you're a developer, DevOps engineer, sysadmin, or anyone involved with managing infrastructure, you've probably heard of Ansible and Terraform. Maybe you've used one in the past and you're considering whether you should learn the other, or maybe you're new to both tools and want to know which one you should use. I've been using both tools professionally for well over 5 years now, and I think they're both great tools for the right job. In this video, you're going to see how Ansible and Terraform compare by using them to do the hello world of infrastructure as code, spin up a publicly accessible EC2 instance, and configure it to respond to HTTP requests. Let's jump in. I'm in VS Code now in a freshly cloned version of the repo linked in the description, which you can also clone if you want to follow along. The code in this repo uses Ansible and Terraform to spin up a publicly accessible EC2 instance along with all its supporting infrastructure like security groups and routing tables, then configures that virtual machine to respond to HTTP requests. By running this code, we'll be able to see exactly where Ansible or Terraform is the best tool for the job. Step 1 is to create the virtual machine and its supporting cloud infrastructure. In terms of infrastructure as code, this step is squarely in the infrastructure management category, and something that Ansible and Terraform can both do. Ansible and Terraform are both infrastructure as code tools, which in my experience fit into 3 main categories: infrastructure management, configuration management, and infrastructure orchestration. In the simplest terms, infrastructure management tools create and destroy the underlying infrastructure you need to run your application. Configuration management tools configure that infrastructure to actually run your application, and orchestration tools run the workflows that can affect all layers, such as application deployments and maintenance like reboots. I've listed some common tools for each infrastructure as code category, and you've probably already noticed that Terraform appears only once in the infrastructure management category, while Ansible appears in all 3. So does that mean you should just stop the video here and use Ansible for everything? I personally don't think so, and I want to show you why. So let's go ahead and provision a publicly routable EC2 instance with Ansible, then do the same thing with Terraform while comparing the code and capabilities each tool gives us. Let's start by looking at the Ansible code to do this in the create.yaml playbook in the Ansible directory. We've got a single play that targets localhost and a bunch of variables like a name prefix, the AWS region, CIDRs for the VPC and subnets, the key pair name and instance type. After that, we have a series of tasks that create the various cloud infrastructure necessary for our hello world. We start by creating the networking foundations of the VPC, internet gateway, subnets and route table, and then move on to creating the security group, getting the AMI ID, and creating the instance. Finally, we print the public IP of the instance so we can start interacting with it. The order of tasks is extremely important here, since almost every resource depends on another one existing first. We share data between the tasks using Ansible's register parameter. For example, we store the details of the VPC in the VPC variable, then use that variable in a number of other tasks, such as when we create the internet gateway. Let's run this code and see what we get. I'll bring up VS Code's built-in terminal and change to the Ansible directory. Next up, I'll export the name of the AWS profile for my dev account, then run time ansible-playbook create.yaml. The whole thing took just 41 seconds, and scrolling through the output, you can see all the tasks creating the various cloud infrastructure, then finally printing the public IP address of the instance. That was honestly a really good experience. We've got under 100 lines of YAML code here, which only took 41 seconds to spin up all our infrastructure. Admittedly, Ansible is perfectly fine at the creation part of infrastructure management, but it really starts to fall apart when you need to make changes to existing infrastructure or tear it all down to start again. For example, let's imagine we're still developing this infrastructure template in dev, and we realize we made a mistake with our subnet CIDRs. Instead of 1, 2, and 3, we want the third octet of each CIDR to be 101, 102, and 103. That should be simple enough. All of this is parameterized as variables, so we could go and we can change the third octet of the subnet CIDRs to be 101, 102, and 103, then bring up the terminal and rerun the playbook. Scrolling through the output, we get changed statuses for our tasks that create the subnet and route table, and finally we get a changed status for the create instance task, and a different IP printed for the instance, indicating that Ansible has created a new one. That all looks fine in the Ansible output, and it looks like Ansible has simply changed our subnets, updated the routing table, and changed our instance, for some reason giving it a new IP. In fact, Ansible has done something pretty terrible behind the scenes, and you'd only know if you took a look at the console. Looking at the instances section of the AWS console, you can see that we've actually got two instances running with the same name, Ansible_instance, one with the old IP and one with the new one. And then if we go and look at the VPC's resource map in another tab, we can see that Ansible didn't change our subnets, it just created new ones and left the old ones unchanged. So now that our infrastructure is all messed up after our change, we're left with the options of going into the console and manually making changes, writing another playbook to bring our infrastructure into line, or we tear everything down and start again from scratch, all of which are either error-prone or time-consuming. For example, even if we want to tear everything down with Ansible, we need to write a whole other playbook to do so, and we need to make sure that everything is torn down in the correct order. I've written a destroy.yaml playbook that destroys everything created by the create.yaml playbook in the correct order, and at 70 lines long, it's almost as long as our create playbook. Not only that, every time we add any infrastructure to the create playbook, we also need to define how to tear it down. So in Ansible, even with a Hello World example, we can't confidently make changes to existing infrastructure, which is already annoying enough, but tearing everything down requires even more code. As someone that's managed infrastructure professionally with Ansible, I can say from experience that this gets exponentially worse as your infrastructure deployments get more complex. In fact, it's this terrible experience that prompted me to go looking for a better solution back in 2016, after which I found Terraform to be a much better tool specifically for managing infrastructure. Let's see how we can create an equivalent set of infrastructure using Terraform. I'll open main.tf in the Terraform directory of the linked repo and start by collapsing all the code in the editor window. Terraform code is structured as blocks, starting with Terraform and provider blocks at the top, followed by a number of data and resource blocks. We use the data block here to get information about the Ubuntu AMI, then create all the same infrastructure as our Ansible playbook. There's the VPC, Internet Gateway, route tables, subnets, security group, and EC2 instance. So far, the structure pretty closely matches the Ansible playbook, and we're at approximately 100 lines as well. If I unfold the code, each block roughly looks like the equivalent task in the Ansible code, but with a different syntax. For example, to create the VPC, we pass in the CIDR block from a variable and give the resource a name. The Terraform variables are defined in a variables.tf file alongside main.tf, and are named exactly the same as the Ansible variables. The syntax for defining variables is different to Ansible, but the values are all identical to what we had in the playbook. Finally, instead of printing the value of the instance's public IP with a debug module, we define outputs in an outputs.tf file. To create all this infrastructure with Terraform, I'll open the built-in terminal and create a new shell tab. I'll change to the Terraform directory, export the AWS profile environment variable, and run terraform init to initialize Terraform's state and pull down any required provider plugins. To create the infrastructure, I'll run time terraform apply. After a few seconds, I get a bunch of shell output followed by a confirmation prompt. Terraform is telling me that it plans to add 10 resources, and scrolling up a bit further, it shows me all the resources it plans to add in a diff-style output. I'll type yes and hit enter to confirm, and Terraform prints all the actions it's taking to create the infrastructure, starting with the Internet Gateway and VPC, then moving to the other resources in the correct order. At the end, we get a success message telling us our 10 resources were created, as well as the public IP of the instance. The whole thing took 39 seconds, as you can see from the time output, which includes all the time we spent looking at the plan for the resources. Let's make the same change to our subnet CIDRs that we tried to do with Ansible. I'll head to the variables.tf file and change the third octet of the subnet CIDRs to be 101, 102, and 103. Now, instead of running terraform apply, I'll bring up the terminal and run terraform plan. The command returns a bunch of output, and at the end we can see the plan is to add 4 resources and destroy 4, and that we'll know our instance's public IP after an apply. As you might have guessed, Terraform plan shows exactly what Terraform plans to do based on the changes in your Terraform files. Scrolling up, we can see that our subnets need to be replaced, and the reason is that a change of CIDR forces the replacement. Scrolling up to the top, we see that the EC2 instance also needs to be replaced, and that the reason is that the subnet ID of the instance will change since we're recreating the subnet. Terraform is smart enough to know not only that the subnets need to be replaced, but also that the EC2 instance depends on one of the replaced subnets, meaning that it also needs to be recreated. Terraform managed to tell us this in advance of making any changes to our infrastructure, allowing us to iterate before we even apply the changes. I'll go ahead and run terraform apply again to see how Terraform carries out this plan. When the command returns, we get an apply complete message, a summary of the changes, and our new instance IP. Scrolling up in the output, you can see exactly how Terraform achieved this as well. First, it destroyed the old EC2 instance, destroyed and recreated the subnets, then recreated the EC2 instance. Once again, Terraform took into account all the dependencies and ordered the operations correctly. Under the hood, Terraform knows about dependencies between resources by building a graph, which you can output and visualize if you want. Compared to Ansible, we've gotten the exact outcome we expected, with no duplicate infrastructure, plus clear details about exactly what happened. To me, this is the single most profound difference between Ansible and Terraform, the fact that Terraform is declarative and state-aware. In Ansible, you tell the system what to do, and in Terraform, you describe the end state you want to achieve, and the system determines exactly how to get there from the current state. State is extremely important in Terraform, and the topic can get extremely complex, but in this simple example, Terraform is storing its complete view of the world in the terraform.tf state file you can see in the sidebar. Every time Terraform runs, it uses this file to determine what infrastructure should exist, updates its view of that infrastructure by hitting the provider APIs, then diffs that against the code to develop its plan. A side effect of this is that we get a way to tear down all the infrastructure without writing any additional code. You won't do this often in production, but in development and testing, you're likely to want to tear everything down and start from scratch pretty frequently. In Terraform, all you need to do is run terraform destroy, and just like terraform apply, you get a full execution plan and a confirmation message before doing anything. I don't want to tear down this infrastructure just yet, so I'll hit enter to cancel. The first time I saw this all work, it was like magic, and it was my aha moment that convinced me that Terraform was the better tool for infrastructure management. Now, the downside of Terraform compared to Ansible for infrastructure management is that in my opinion, it has a much steeper learning curve, and for any non-trivial production system, you're going to need quite a lot of setup, particularly in terms of state management and folder structure. Honestly though, I think Terraform's setup and learning curve is worth it for what you get, especially once you start creating your own Terraform modules, which are essentially abstractions around whole sets of infrastructure that you can create like any other resource. Now, what about configuration management and orchestration? As we saw earlier, Terraform just doesn't do either of these. If you wanted to update some configuration or restart a service on your instances, or you wanted to reboot them to apply updates, Terraform simply doesn't give you the ability to do it. These are classic configuration management and orchestration tasks, and in my opinion, this is where Ansible really shines. Let's see just how easy it is to use Ansible to start managing the instances we just created. The first thing we need to do is tell Ansible about our instances in a hosts file. I've got an example hosts file in this repo which I'll copy and paste, then rename to hosts. In this file, we've got two hosts, one called Ansible and one called Terraform, and on each line we tell Ansible the IP of the instance and which user to auth as with the Ansible host and Ansible user variables. I'll copy the IPs of our instances from the Ansible and Terraform output in the terminal and paste them in the hosts file. Creating a hosts file is all we need to do to start managing our VMs with Ansible, and I've written two tiny playbooks to demonstrate just how much you can do with Ansible with very little code. The first playbook is called configure.yaml, and it shows how you can do configuration management with Ansible. It's 27 lines of super readable and self-documenting YAML, which tells Ansible to install Nginx, modify Nginx's default site configuration, then uses a handler to reload the Nginx service if and only if the task to update the configuration makes a change. The site config task uses variables in its template, which are automatically set by Ansible for each instance. On top of this, Ansible is going to manage concurrency for us and give us readable output. That's a huge amount of power with very little code, and no agent required on the remote host. I'll bring up my built-in terminal and run this playbook with ansible-playbook configure.yaml. In the output, we see changed statuses for all the tasks from the playbook as Ansible installs Nginx, updates the Nginx site configuration, and reloads Nginx on both our hosts. I'll grab the IPs of our hosts and visit them in Firefox. I get a big hello from the IP of the host we spun up with Ansible, and another hello from the host we spun up with Terraform, showing how Ansible has populated the variables in the template. This is such a powerful base to build off of. For instance, with a few more tasks in the playbook, we could clone a Git repo with code for a web application, configure a systemd service to run our code, and update Nginx's configuration to proxy the web app. This is something I cover early in Chapter 2 of my Ansible course, and that's only scratching the surface of what you can do with Ansible. The other Ansible playbook I included in the repo is called orchestrate.yaml, which is a super simple example of how easily you can do orchestration-style tasks with Ansible. This playbook does what's called a rolling restart in only 19 lines of code, meaning that it reboots all our hosts one by one, waiting for each reboot to succeed before continuing. The first task reboots the host and waits for it to become accessible again via SSH before continuing to the next tasks, which get the uptime of the host and print it to the output so we can confirm the host was really rebooted. We tell Ansible to run one host at a time by setting the serial key on the play to 1. I'll bring up my built-in terminal and run this playbook with ansible-playbook orchestrate.yaml. In the output, we have a block for each host, starting with the host called Ansible, where Ansible restarts the host, waits for it to come back up, checks the uptime, and then prints it to the output. This is repeated after for the host called Terraform. This was a super simple example, but like our configure playbook, with a few extra tasks, you could do things like update a load balancer to remove the host from routing, upgrade the kernel, or update some other software packages before rebooting. In my Ansible course, we use orchestration to configure streaming replication between two Postgres databases and failover between them. After all this, it shouldn't be surprising that my final recommendation is to use Terraform for infrastructure management and Ansible for configuration management and orchestration. What do you think? Let me know in the comments about your experiences with these tools and if you agree with my recommendation. I've mostly focused on Ansible content so far, but if you want to see more Terraform content or comparisons like this, or have any trouble with the code, please let me know in the comments as well. Thanks a lot for watching, and I hope you found this video useful.